Welcome to this explainer. We're diving into the totally unseen yet absolutely critical steps that keep massive industrial machines from, well, tearing themselves apart. Have you ever walked past an industrial plant and felt the ground actually humming? That's the power of gigantic pumps and compressors spinning at mind-boggling speeds. But how do they stay anchored to the earth? Today, we're breaking down a fascinating microprocess for rotating equipment installation that makes it all possible. Formwork and the before grout inspection. Let's get into it. Okay, here's our roadmap for today. We're going to cover 1. Rotating equipment's challenge. 2. What is formwork? 3. The pre-grout checklist. 4. The anchor box secret. And finally, 5. Ready for grouting. Let's move right along.
All right, Section 1, Rotating Equipment's Challenge.
So it's a fascinating question, right? Think about your washing machine at home when the load gets unbalanced. It shakes, rattles, and practically dances across the laundry room floor. Now, take that force and multiply it by 10,000. Industrial rotating equipment generates a literal ton of kinetic energy. If these massive pumps aren't perfectly secured to the ground, their own vibration will literally destroy their internal bearings, snap connected pipes, and cause total catastrophic failure. Not good. Well, the secret to their survival comes down to two big things: grouting and formwork. Grouting is basically an industrial superglue. It's this incredibly high-strength mixture that fills the gap between the machine's steel base and the concrete foundation, locking them together forever. But you can't just dump this liquid glue on the ground and hope for the best, right? You need formwork. That's the highly precise, temporary mold built right around the equipment to hold the liquid grout exactly in place until it cures into solid rock. Moving on to Section 2. What exactly is formwork? To put it simply, think of formwork like a baking pan made out of plywood. If you're baking a cake, you obviously need a pan to hold the batter so it doesn't spill all over the oven. Formwork does the exact same thing for our liquid grout. But here's the catch. Industrial grout is unbelievably dense and heavy. So this plywood mold has to be built flawlessly. If the boards are too thin or if the joints aren't sealed super tight, the immense pressure of that wet grout will actually blow the wood apart or leak right out through the cracks. It is a serious precision woodworking job for a really heavy engineering task. You can actually see exactly what we're talking about right here. Look at that heavy rotating equipment sitting perfectly leveled on its foundation. Notice that wooden perimeter hugging the bottom edge? That is the completed formwork. It's securely braced, tightly sealed against the concrete, and creates this perfect little tub just waiting for the liquid grout to be poured inside. Next up, Section 3, the pre-grout checklist. This is the detective work we have to do before any pouring happens. Okay, so we have 4 absolutely critical checks to ensure the foundation is prepped for a beginner-perfect installation. First, the concrete surface has to be chipped or really roughened up. Grout won't stick to smooth concrete. It needs physical, jagged peaks and valleys to bite into. Second, there must be absolutely zero dust, dirt, or debris left behind. Third, the water saturation has to be spot on. And fourth, as we just saw, that wooden formwork needs a thorough inspection to make sure it's sturdy enough to handle the weight. Now, that water balance I mentioned, it's fascinating. Why saturate the foundation? Because if you pour wet grout onto bone-dry concrete, the dry concrete will act like a vacuum and suck the moisture right out of the grout. That ruins the chemical curing process and makes it super weak. So workers actually spray the concrete with water for hours beforehand to make it like a damp sponge. But, and this is absolutely crucial, there can be no pools of standing water. Puddles will dilute the mix and completely ruin the bond. Damp? Yes. Puddles? No way. And to make sure nothing slips through the cracks, inspectors use a very rigid inspection format. They physically check the rough surface, they review the lab test reports to ensure the specific batch of grout powder on site will actually reach the massive strength required by the engineers. Literally, no guesswork is allowed here. All right, Section 4, the anchor box secret. So here's a huge difference in how machines are bolted down. For stationary stuff, like a giant storage tank, the steel anchor bolts are just shoved directly into the wet concrete on day one. They're locked in forever. But rotating equipment, totally different story. Pumps need alignment accurate to a fraction of a millimeter to line up with their piping and motors. You literally cannot do that if the bolts are frozen in concrete. So instead, they use empty pockets inside the foundation called anchor boxes. This gives the bolts some wiggle room to shift until the alignment is absolutely flawless. Take a look at these square holes cast right into the concrete foundation. Those are your anchor boxes. The machine is going to be lowered down, and its long steel bolts will drop perfectly into these empty pockets. Then, once everything is leveled and aligned, those pockets get filled with grout to lock it all in. But here's the massive headache for the installation crew. Since these boxes are literal holes in the ground on a messy construction site, they are absolute magnet traps for junk. They fill up with rainwater, loose concrete chips, dropped screws, you name it. So climbing down there with a flashlight and a vacuum to clean out every single one of these boxes is the most vital and, yeah, usually the most tedious part of the whole pre-grout inspection. Because if even one piece of trash is left at the bottom, the grout won't bond, and that massive pump could literally rip itself right out of the ground when it turns on.
Okay, final step, section 5, ready for grouting.
Right next to that pristine, perfectly damp foundation, the team gets to work. They precisely blend the high-strength grout powder with exactly the right amount of water in the mixer to get the perfect pouring consistency. It's a real race against the clock, too. Once it's mixed, the chemical reaction starts right away, so they gotta pour it quickly and steadily. And here is the final payoff. That thick, heavy liquid grout is carefully cast right into the formwork. It flows right under the machine's steel baseplate, filling every tiny microscopic gap on that rough, chipped concrete. And most importantly, it cascades down into those super clean anchor boxes, completely engulfing the steel bolts. Once it cures, the machine, the bolts, and the earth basically become one single, unbreakable solid unit. So, to recap our roadmap real quick. Step 1, build tight, flawless formwork. Step 2, pass that rigorous pre-grout inspection, rough concrete, damp surfaces, spotless anchor boxes. Step 3, pour the grout perfectly. This simple 3-step process is what guarantees the violent vibrations of rotating equipment are safely absorbed straight into the ground. It really makes you stop and think, doesn't it? We look at towering refineries and power plants, and we're amazed by the giant steel structures. But the truth is, a multi-million-dollar compressor relies entirely on a few pieces of well-cut plywood, a worker meticulously vacuuming dust out of a hole, and the exact right amount of water, just to survive its own power. It's these invisible microprocesses that quietly hold our modern world together. Thanks so much for joining me on this explainer, and keep looking deeper into how our world is built.